Assalamualaikum and salam sejahtera to our lecturer, TS Dr. Henry Fitrian Suhandri, and also our fellow friends. Today we are going to present our project, which is application of GPS, GIS and RS in civil engineering. Okay, before we start our presentation, let me introduce myself first. My name is Naimah Salleh and I will present about introduction and also remote sensing. Okay, for introduction, what is GPS? GPS is a radio navigation system that allows us to determine the location, velocity and times within 24 hours a day in all weather conditions and anywhere in the world. Next, what is remote sensing? Remote sensing is the science of acquiring information about a surface without actually being contact with it. This is done by sensing and recording reflected or emitted energy or processing, analyzing and applying that information. And lastly is GIS. GIS is a geographic information system that incorporates hardware, software, and data for capturing, managing, analyzing, and displaying all forms of geographically referenced information.
Assalamualaikum. Okay, now we will go to the application of GPS in civil engineering. Okay, the first one is GPS in civil engineering survey. Surveying is one of the important and crucial things that need to be carried out before executing any construction work, because any planning and designing of civil engineering work are based on the surveying measurement. GPS positioning technology can be implemented during the surveying process due to its significant advantage, which is providing a high accuracy data measurement. A paper written by Zhan Wu discuss on the application of GPS mainly in civil engineering survey on three main applications, namely on bridge engineering survey, line survey, as well as urban engineering survey. Okay, the first one is bridge engineering survey. GPS can greatly improve the accuracy of the survey during the project, as it can be used for elevation measurement and cross-river inspection and measurement work, so that it can help in improving and optimizing the design level of the bridge. Then, for line survey, GPS can be used in a long-distance off-road monitoring and the monitoring of line project with relatively complicated terrain. Then, for urban engineering survey, GPS positioning technology can also be used for monitoring during the construction process, such as identifying the location of piles for high-rise building, as well as dynamically monitoring any deformation settlement. Okay, then we move to the GPS in monitoring existing structural deformation. Monitoring of any structure deformation involving large and tall structure require a high accuracy measurement. So GPS technology have a high potential to be used as a valuable tool for this purpose. A study by Wan Aziz used real kinematic GPS or RTK GPS to monitor the structural deformation of tall structure, namely Menara Sarawak Enterprise. In the study, two types of data were obtained for analysis, namely RTK GPS and static GPS observation data. And from the data analysis, it was identified that the deformation displacement at Menara Sarawak Enterprise building is not detected. Then, study by Handayani focused on monitoring the deformation of Suramadu Bridge in Indonesia by using GPS technology and also close-range photogrammetry. GPS was used in order to monitor the deflection in the middle of bridge by kinematic methods using precise ephemeris data for correcting coordinate. And the results showed that there are deflection occurred in both horizontal and vertical axis based on 3 times of observation.
Okay, next I will explain about application of remote sensing in civil engineering. Remote sensing images have been widely applied in the spatial data extraction in various disciplines such as environmental monitoring, mapping and land use planning. Okay, I will talk about remote sensing in building construction and also railway construction. So for the first one is remote sensing in building construction. Vietnam has explained in their journal that the features recognition technique that automatically measure the actual progress of different locations in the project using high-resolution satellite remote sensing image. The main benefit of the proposed system include the automated measurement, enhanced visualization, and documentation of plans or actual progress in large linear projects. Thus, this kind of application can help in reducing the time consuming while doing the task and also the complexity of the task. The next study is by Ye Piraste on 2017, which is an investigation of the spectral characteristic of building materialistic in wavelengths. The research explored a new method for identifying color steel, clay, glaze tile, and asphalt concrete using hyperspectral remote sensing based on building material spectrum characteristic. The result shows that building surface materials can be identified from hyperspectral remote sensing image with a reasonable quality based on the spectral sensitivity of different building material. In conclusion, the proposed method based on hyperspectral remote sensing image and spectral recognition techniques is an efficient way to extract information about building materials. There are also research by Wombley and Mehta about the application of remote sensing in civil engineering, which is in identification of changes in damage of building after some incidents and natural disaster. Remote sensing enables engineers to see the damage condition in inaccessible area and also preserving critical damage evidence. Next, I will talk about remote sensing in railway construction. In the article by Vikram Sanghe in 2017, the article presents an integrated remote sensing change detection framework applied to monitor the light rail transport construction in Kuala Lumpur, Malaysia, using submeter optical remote sensing image plates. Focusing on the unknown local area surrounding a construction site, the recognition process starts from the completing stage, checking condition based on the predefined rules, applying the recognition process corresponding to the stage, and then moving to the immediately proceeding stage if appropriate. Next, there are also a study that carried out a research about the developing automated method to recognize railroad infrastructure from 3D LiDAR data. Railroad infrastructure include the rail tracks, contacts cables, catering cables, return current cables, masts, and cantilevers. The LiDAR dataset used in this study is acquired by placing the Optec Lens mobile mapping system on the rail car, operating at 125 km per hour.
Hi, my name is Stefi Zamsari and I will talk about the application of GIS in civil engineering. Civil engineering is about the development and maintenance of infrastructure and structure. So, the civil engineer cover many areas of interest and wide range of expertise. As a result, they work with a huge amount of data from the variety resources. As example, infrastructure, water resource, site analysis, geotechnical, and others. So, with the GIS, it helps a lot and improve to the civil engineer. So, GIS is stand for Geographic Information System. It provides a tool that creating, managing, analyzing, and visual the data associated with developing and managing infrastructure. Then, it allows engineer to manage and share data, which can turn it easily to understand report and visual on that can be analyzed and communicated to others. Then GIS also help organization and government work together to develop strategy for sustainable development. Actually, GIS technology provide a central location to conduct spatial analysis, overlay data, and integrate other solution and system. So, GIS enable civil engineer easily to manage, reuse, share, analyze data, and saving time of resources. Actually, there are many applications of GIS in civil engineering, but we more focus on the GIS in site analysis. S3 2012 stated that GIS can analyze many types of information and image for site analysis. Highly accurate results make it easy to recognize map. So the base map include parcel map, zoning and city designation, environmental protection area, aerial photography and soil maps. So the civil engineer use GIS to keep track of multiple urban and religion indicator, forecast future community needs and plan according to guarantee quality of life community for everyone. According to Rikalovic 2014, industrial site selection is critical point in the process of starting, expanding or changing the location of industrial system of all kinds. It have a spatial problem, which the problem involve a large set of feasible alternatives. In the site selection process, need the analyst strive to determine the optimum location that would be good and satisfy the selection criteria. So to have the appropriate method to detect all these problems is by using GIS. Since GIS are powerful tools designed for spatial analysis which can provide a capture, store, analysis, display and output the geographic information. There are also other systems such as the System for Decision Making (DSS) and System for Multi-Criteria Decision Making (MCDM). A clear need for such a model as a decision support system allows efficient solution to solve the problem in the site analysis. Next, we will talk about the GIS in infrastructure management. GIS is the core system for data management and visualization. So having an accurate, clear picture of the project can help the civil engineer to understand much better in terms of need, reduce problem, mitigation costs, and environmental impact. GIS can provide the best mapping and visualization on and also present the information in straightforward way. GIS also an effective tool in environment, transportation, hydrological and another infrastructure study. So, Wegman and Patil 2019 state that the concept of infrastructure management have evolved increasingly through changing the demand of the human need and environment. So, it need any method or software to infrastructure planning. So they provide that GIS is the best software application for this main purpose, which it can access and analyze spatially distributing data with respect to its actual spatial location overlaid on the base map on the coverage area. They also do some research on how GIS application work to urban and rural work network. So, the primary and secondary road system is taken the existing religion road of the area and the new rural and urban road link are added to it in a prioritized. So, the work network data of study area not have the alignment of existing path and track, so which are not included. So, using GIS, there are various input of data can get and the maximum accessibility rural and urban road network to overcome this problem. Okay, the last but not least is the GIS in water management. Size 1996 that GIS makes it easier to develop computer application to address the problem of storing, manipulating and analyzing large volume of spatial data related to the water resource. GIS can be utilized efficiently in water resources modeling, which is been used to predict and monitoring non-point source pollution from agriculture area and urban environment, to monitor low and pollutant in storm sewer network, and to assist the contingency plans and environmental impact assessment. GIS provide the best function in the water management with it updating and collecting data directly in the field. As example, the positioning of point, lines, polygon and input attributes. The application of this GIS is the water resource is give the scale of the problem, and it's possible to illustrate in water management application, flood protection, flood crisis management, flood extent, survey and others.
About the discussion, the cost overrun and schedule delays are common problems frequently leading to disputes and costly claims in the delivery of construction projects. So, all the GPS, remote sensing and also GIS technology really give big impact on construction industry, as they can help in many aspects of works and operation. Then, for the conclusion, there are ample evidence of applying the recent advance of satellite based on GPS, remote sensing and the GIS technology in various fields of civil engineering as discussed before. Hence, the civil engineers expert must take the advantage of this advanced technology in order to increase the development rate in the country, as Malaysia is a developing country. Thanks for listening.